let's go ahead and take a look at some of the key ingredients of a probability distribution of a random variable. So in order to officially have what we call a probability distribution, there are two conditions that need to be met, which are right here. And so when looking at these examples here of these tables, they look like distributions, right? In the sense that here are your outcomes, here are the probabilities, or the proportion of times those events occur. And so when you look at that, you're saying, okay, what's going on here? And each of these are not officially probability distributions of a random variable, and they do not meet all the requirements. On the first one, the outcome variable, the variable x, right, the random variable, is not a quantitative variable. It needs to be, for us to have it, there needs to be a quantitative variable. And so you'll see that heads or tails are categorical, so those do not, it's not quantitative, so it's not a valid probability distribution of a random variable because this is not discrete or continuous variable, which are for quantitative. In the second one, what we have here is we don't have enough data. It's not finished. Why would this not be? Well, if you look carefully here, you add the probabilities up, you get 66. So we're technically missing, right? Why? Because we're missing some value. So it's not a complete probability distribution. It doesn't represent all, right? Sum of all the probabilities. It doesn't represent all of them must be equal to 1, which means we don't have all the data there. So those are examples that are not probability distributions. Just to keep that in mind, okay? And what we're going to do with these probability distributions, which becomes important, is we're going to calculate what's called the expected value and the standard deviation in variance for those distributions. It becomes a very important idea as how we apply probability to the real world. Is we're able to now calculate what we would expect. What's the value? What value would we expect in the long run? And so here's an example. Well, let's do an example. Before doing an example, I just want to make sure you have this information. It looks very complicated. This expected value is also considered to be called what we call the mean. There it goes. The mean is the expected value. The mean of a random variable is the sum of every value in the table times its probability. And this just means sum right there. That symbol is means sum, to sum up these values here. And the interpretation is in the long run, over many trials, the outcome are going to average to this here, which is, you remember from earlier, that's the mu symbol, or the average, right? That's the mu. That's going to see what we expect. We have some, again, they look complex, but they're not. And we're going to end up using technology also to help us out here, calculators, to calculate the variance. If you have a mean, then we need to know what the standard deviation or variance is, and you have these values here. And here is the formula here, which we'll practice once. And then to calculate the standard deviation, which is here, the abbreviation SD, it's just the square root of the variance. And we learned that in a previous section when we looked at measures of center, measures of spread. We're now just going to apply this to probabilities. And the interpretation of standard deviation, in the long run, over many trials on average, we will get this value, right? That's standard deviation, units away from the mean. So you can get a sense of the distribution, how far the data values are.